Okay, for the first question, the resistance of the two resistors that we measured are 100 ohms and 40 ohms. And for the resistors that in series, the total resistance is 140 ohm. And for the resistors that in parallel, we calculated is 140 ohms. And for the question D, the first resistor is 100 ohms and the second resistor is 10 ohms and the third resistor is 83.3 ohms and the fourth resistor is 40 ohms. For the problem E, first we use this formula to calculate the resistor that in parallel, which is 45.4 ohms, and we used this formula to calculate the resistors that in series, which is 50 ohms, and the total resistor for these four resistors is 95.4 ohms, and the total resistance that we got is 93 ohms. For the question F, we use this formula to calculate the current, which is 0.009 and the voltage of the resistor is 9 volts. And for I, we measure is 0.008 and for voltage we measure is 8.6. For the question B, it's because the solar cell is a kind of sensor. As the solar cell is near a light source, it will make the audio to produce a noise. And for the question C, the frequency is 320 Hz. And for the question D, the sound emitted by the application is converted into a regular current because the current change leads to the regular flashing of LED lamp after being received by the solar cell is converted into a current to produce a sound with the same frequency as input. And for the question A, the forward voltage is 2 and the forward current is 100 mA. For the question B, use the Ohm's rule to calculate the resistance, which is 140 ohms. And for the question D, the resistor is to prevent the LED from burning out and the current is the same everywhere in this current. Therefore, whatever the resistor comes before or after the LED, it will protect the LED. And for the question 4, use the same step and the same formula to calculate the resistance, and it's the same as the question D. And for the question 8, it's because the light wave is a kind of light wave. Because the change of sound wave affects the change of light wave, so the light wave received by solar circuit board has a certain change, because of which makes the magnitude of electric current change, thus producing sound. And for the question 9, First, we hear two different sounds, and then the two sound waves interact with each other, making the sound smaller. And for the question 10, first I estimate that the frequencies and then use the frequency generator to generate the frequency and play the video at the same time. There will be a bit frequency because these two frequencies are different. Then I changed the frequency until there was only one frequency, and the frequency that I estimated is 1800 Hz, and the accepted value I calculated is 90.5 1805, and the error is 0.0028, and percent error is 0.28%. And for the question 12, as I rotate the paradio and the sound diminishes but doesn't disappear because light is a type of wave. The parallax blocks part of the wave from reaching solar cell. And for the question 13, as we rotate the parallax, the sound diminishes until the sound disappears. No contradiction because the experiment proves that the light waves are transverse waves, and because they are transverse waves, they can be blocked by the polarizers. And that's all.